partial fraction decomposition. So what this big fancy word means is that we're just going to take a big fraction and we're going to break it up into smaller fractions. For example, we might have a fraction like 5x minus 3 over x squared minus 3x minus 4. So what partial fraction decomposition is again, we're just going to take this fraction and we're going to make it into smaller fractions. So the first thing we want to look for is the denominator factorable? And in this case, we can actually factor this into x minus 4 and x plus 1. Okay, and the numerator will just stay the same. And you may be wondering, why did I write two different linear factors up here? Well, the reason for that is that both of these factors are linear, and that's because x is to the first degree. Okay, so now we want to write it out just like this. We're going to write out two fractions because there are two factors. And each of the fractions are going to have denominators of the factors. So the first fraction is going to have a denominator of x minus 4. The second fraction is going to have a denominator of x plus 1. Alright? And the numerators, we're just going to leave them as a and b because we don't know what they are. Now we have to solve for the numerators, and that's it. We've broken up the fraction. So I'm going to just erase this for now. So there are two ways that we can go about solving for the a and b. I'm going to show you both of them, but I'm going to show you the faster way first. So the faster way is we just multiply both sides by x minus 4 and x plus 1. So what that will do for us is that we'll completely get rid of the denominator on the left side, and on the right side we'll just have the unused factors. So x plus 1 is unused in a, and x minus 4 is unused in b. So again, all I did was just multiply by the factors on both sides of the equation. I just multiplied x minus 4 plus times x minus 1 to this side, and I multiplied x minus 4 times x minus 1 to this side, alright? And you end up with this equation. So now the shortcut is just to plug in a value that will make this 0. So what value makes this 0? Well, negative 1 plus 1 is 0. So we'll plug in negative 1. And when we plug in negative 1 for x, we get that negative 8 is equal to negative 5b. And so we'll then say that b is equal to 8/5. Okay, that's it. And we'll do the same thing for a. So in order to solve for b, we want to cancel out a. So we'll plug in 4. And when we plug in 4, then we get that 17 is going to be equal to 5a. Okay? And so a is just 17/5. Right? And then we just plug in both of these values into our a and b, and we're done. Now there is another way that I just want to quickly show you, is just by distributing the a and distributing the b. And when we do that, then it's going to look like this. It's going to look like ax plus a is equal to bx minus 4b. And the reason I'm showing you the longer way is because sometimes it may be easier for you to do it this way, or maybe your brain just thinks of doing it this way. Okay, so we're gonna see what are the like terms. So we see ax and bx are like terms, so we're gonna group them together. So it's a plus bx, and a and minus 4b is also like terms, a minus 4b. And now we're gonna use the corresponding coefficients in order to solve for a and b and get a system of equations. So we see that a plus b must be equal to 5 because those are the corresponding coefficients. So we'll say that 5, right, is equal to a plus b. And we'll say that a minus 4b is equal to negative 3. We'll say that, yeah. So we'll say negative 3 is equal to a minus 4b. And so we just solve this system of equations, and we'll get that a is actually equal to 17/5 and b is equal to 8/5. Alright? So when we plug these back into our original equation, it may look a little funny that a is an improper fraction over another fraction. Well, you get what I mean. Okay? So we have fractions in a fraction. So how do we deal with that? Well, this confused me at first, but I want to show you the solution. We see that both of the denominators end in a 5. So what we do, we just pull out a 1/5. And we're left with 17 on this side. And we're left with the 8 on that side. And that's it. Boom. You've successfully decomposed this original fraction. We could just write it back in the way it was originally. And that's how we do it.